Okay guys, now we are talking about data type and the constants in C++ programming language. So before doing that, we are going to take a review on the number systems. What are the number systems? When we are saying number system, that means the numbers in real life can be represented in variety of ways. So we've got a variety of the number of systems, and this representation of each different number system can be done using the base, and the numbers are going to be written in this way: the number itself and the base of it. For example, we've got four main different number systems, which are decimal, binary, octal, and hexadecimal. And the decimal are the commonly used numbers, and the valid digits from 0 to 9 are real numbers we are using nowadays. For example, 126, when it is written, the base is 10. That means it is a decimal number, and it's normally written as 126. We are not using that 10. And we've got binary numbers, and the base of the binary numbers is 2. For example, this is a binary number, and the valid digits of the binary numbers are zeros and ones. So this is a binary number. Why? Because it is written that the base of this number is 2. This number can be a decimal number, but when we have 10 instead of these two here. And we've got octal numbers. The base of the octal numbers is 8. So the valid digits are from 0 to 7. For example, 176, when the base is 8, that means it is an octal number, it's not a decimal number. And we've got hexadecimal. We need to write down 16. Why? Because the base of the hexadecimal is 16, which starts from 0 to 9, and then from 10 to 15 we don't have any numbers, so we are using alphabet numbers: A to 10, B to 11, so we are going to 15, which represents by F. So we've got this number 7E, and the base of it is 16. That means this number is a hexadecimal number. Okay, what are the integer data types? You've got some integer data types which are designed to hold the numbers, any number we are having. So they can be signed or unsigned. For example, this one is unsigned, this one is negative sign, this one is positive sign. So when we have a number and we have some different numbers, the size of each of them is different. So we've got those three different types, different integer types: short, int, and long. So the short is the smallest one, while the long is the biggest one. So we can store any variable or any data or any constant inside a long memory location by writing down L at the end of the number or the data. And any constant begins with 0, that means this is an octal number or the base 8 number. And any constant that begin with 0x, that means it is a hexadecimal number or base 16 a number. And the definition of the variables. So we've got, for example, some different types of the variables: integers, long or short or whatever, a character or any other data types. So when we have same type of the variables, for example, those two variables, length and width, are in the same type, they can be defined and in two different statements. For example, int length semicolon, int width semicolon. This one is a statement, this one is another statement. Each of them is called a variable definition. So we can define them in two different statements, and even we can define them in the same statement: int length comma width, then semicolon. That means we have defined those two different variables inside one statement. But variable of different types must be you have to define them in separate statements, while the variables are in different types. Now in here the variables are in the same type, so we can define them in single statement. How about representing the floating point data, and what are those data types which are made in order to hold the floating points data? For example, we've got those three different variables: float, double, and long double, while the float is the smallest one and the long double is the highest one, and all of them are signed. And we can represent them in fixed point or decimal notation, like this number and this number, from this one to this one, or E notation, from this number E1 up to this number 25E minus 5. So they are double by default, and they can be forced in order to be float by writing down F at the end of the number, or long double by writing down L at the end of the number. Okay, when we are assigning a floating point value to an integer variable, for example, we've got int rainfall, so this value must be integer. But so what if we give it a number with some fractional part, or a floating point value to it? So what happens here? It truncates, it discards, it ignores the fractional part. It only remains with the real part of the number. For example, when you say int rainfall equals to this number, C out rainfall, what's going to be the output? Only 3. It doesn't round it, it only discards or chops off or truncates the fractional part. And we've got another data type which is called bool, which represents the value that are true or false, or we've got only two choices of some situation. So in this case we are using bool data type, and they are stored in a small integer. So what is going to be stored in memory? Only one bit, whether it's 1 or 0. For example, we are defining this variable all done, which its type is bool. We are saying bool all done equals to true or equals to false. So in this case 1 is going to be stored inside the memory, while in this case 0 is going to be stored inside the memory. So we've got this variable and this variable, so each of them has its own data. And we've got a char data type, which is which is having only a small amount of data, occupies 1 byte of memory. And for example, we can define this one: char letter equals to C. And you need to know that when you are giving or when you are initializing a char variable, you need to put the data or the value inside two single quotations. Okay, so what is going to be stored inside the memory? We can't store this one. Only the number which represents this value is going to be stored inside the memory. So this is the memory going to be the memory location of this variable. This 67 is going to be stored, and this one is going to be converted to binary, then it's going to be stored inside the memory, because the memories are only accepting zeros and ones, so the letters are not stored inside the memory. The numeric code representation of the character is going to be stored inside the memory. What is wrong with this program? This is alright, this is alright, this is alright. We are defining char letter, we are initializing the letter, we are giving it a value. But as I said, any value which is being given to a char variable must be between two single quotations. These are double quotations, so this is wrong. Okay, this is what is wrong of this program. And this is the summary of the data types: char, short integer, integer, long integer, boolean, floating, double, long double, and these are the size of each of them. So what is the description of each of them, or the size of each of them? But this is we have said long integer is higher than integer, but they are both occupying the same size inside the memory, which is 32 bits.